Hi, my name is Priyanka Singh. I'm a graduate student at the University of California, Riverside, here to tell you why renewable fuels is not optional. In order to make renewable fuels and chemicals cheaper, we must unlock all the carbon from within the plant cell wall. There's no carbon left behind effort will help us to reduce our dependence on finite fossil fuels and lower greenhouse gas emissions. The carbon in plant is complex. We'll call it polysaccharides and lignin. Polysaccharides are repeating units of simple sugars. Lignin is a complex polymer that makes it difficult to separate out and can even impede the conversion of sugars downstream. What we want to do is create sustainable products from these things by breaking them down in as few steps as possible so that we can really bring down the cost barrier. The approach I'm taking to do this uses an advanced pretreatment method called co-solvent-enhanced lignocellulosic fractionation, or SELF. SELF effectively fractionates biomass into a solids fraction that is rich in one type of polysaccharide called glucan, and a liquid fraction that renders lignin in a separate stream. This is the icing on the cake, as now lignin is easy to separate out. What we have done is fine-tune the time and temperature of the SELF reaction to expose as much glucan possible to be converted to something useful, like ethanol, in a process called fermentation. The fermentation we paired with SELF is a game changer. It utilizes a multifunctional ethanol-producing organism that produces its own enzymes that then breaks those sugar molecules down in order to convert and create ethanol in a single step. Basically, this is great because it reduces costs of adding additional enzymes. What the results that came about pairing these technologies was really that we were able to solubilize 90 to 100% of the glucan present in solids over a wide range of conditions. This even happened in some conditions at after 5 minutes of pretreatment at low temperature. Another additional benefit to this was the fermentation process, which usually takes 5 to 7 days, was now reduced to 1 to 2 days. By finding a bunch of conditions that allowed glucan to be converted, we now have a large range of conditions to pick from to find something that also maximizes the amount of lignin in stream so that we can convert that also. All the insight we gain from combining these processes will allow us to create a circular economy and do something bigger with these renewable products. The technology we're developing at the University of California, Riverside has the potential to overcome current cost barriers in producing these fuels and chemicals. It is efficient in fractionating biomass and recovering almost all the available carbon. It also minimizes enzyme cost, and it co-optimizes an upstream separation process with a downstream conversion process for greener fuels and chemicals, which will allow us to reduce our dependence on finite fossil fuels. Thank you.